So, good evening, everyone. Let us start today's session. So, can you able to see my screen? Okay, thank you.
Yes, ma'am.
Okay. So, in today's class, we are going to see about how to create make files before the title. So, debugging and profiling. Okay. So, yesterday we have seen something about NV profile, NV prof. Okay. So, uh, some detailed explanation for all those things we can see today. You know what is the make file? Okay, so already if you have developed some applications, so okay, if you want to execute, you can use make file. So it is having some set of files, and so you can use make files when we have some dependencies among the different files. Okay, if you are developing some large project, so we may have more than one files, and one more than one files may have some dependencies. Okay, and so if you want to combine all those files and execute, so we can use make files. Okay, and okay, we are having some commands. We are putting all the commands in a single file, and that directory is mainly used for running the command make. Okay, so the make file may be executed with a command called make. Okay, so the syntax is so common to all. You are having some target. So write what are the prerequisites. So and what are the commands you needed. Write everything in a single file. So and run using the make command. Okay, and the targets may be the file names. What are the most of the cases it is a different file names. Okay, you can write the different file names with separated by column, and the commands are the series of steps. All the files needs to be executed. Okay, so here the commands start with a tab. Okay, not any space. So, for example, hello, if you are using Linux, okay, Linux command prompt, okay, so we can write echo hello world, and so if this is written on some file and you make that, okay, what happens is hello world will be printed. Okay, so like different programs, you can use make file in CUDA program too. Okay, so already we have seen this particular program here. What we are doing is uh, we don't execute, we are not calculating anything here. Just we are printing the hello world. How many times? 32 times it will be printed. So one block is used, but we are using 32 threads. All the 32 threads are executing the same kernel. So it will be printed 32 times. The world will be printed 32 times. Okay. So you can write the make file like this way. Okay. So rename hello. So the executable code you can write it inside. So after that you can write what it will be, how it will be executed. Okay. So then you can call the make. Okay. So the output will be given. And variables. Okay, so in make files you can use variables too, and the way all the variables must be in strings, and here you have to use colon equal to for assignment operators, and all the reference variables you can use either dollar this bracket or dollar this bracket. Okay, file 1, file 2, file 3, and the reference variables. Okay, all these things are have been used here. Okay, so you can write it in this way, and also you can write the multiple targets. Okay, here we are having H1, H2, and H3. H1 what it has to do, H2 what it has to do. So all the files, what we are doing is we are simply so compiling the CUDA program and running the program. Okay, that happens in all the things. Okay, once everything is completed, you are removing. Okay, so you may have multiple targets, call one, call two, call three. So you can write in this way also. Here we are having three targets. To write all the three toggles. All the three toggles are using the same thing, no. So you can write in this way too. So also we can write something, some conditions in make file. Okay. So if equal to this, target CPU equal to 1. Else, so target CPU is, if it is like this, target CPU, again the same thing is assigned here. So else you are assigning that particular variable equal to 0. So in this way also you can write the conditions in make files. You can also write them loops, how many times that has to be executed. Okay, the slash represents the all the statements, the following statement has to be written in a single line. Okay, if you are not writing in a single line, you can write the slash. This is a complete program. It is having the while loop, and once everything is completed, it is removing all the unwanted files from the execution directory. So next we'll see what is debugging. Okay, and if you have written some parallel programs, debugging is very very difficult. So because already I told, if you have wrongly given some uh, thread numbers and block numbers in the while launching the kernel, the GPU won't give any error message. Okay, so it try to execute something, otherwise it won't give it some results. Okay, so also in some programs, already in the previous class we have executed, there are some errors are there, but it won't raise some error. Okay, so if you want to get some error, you have to use some error coding statements. Then only we can able to catch the errors. Otherwise, it is very difficult to debug the parallel programs. Okay, because of the thread scheduling, the all the outputs can be maybe different. See, if in some cases the intermediate values are very large, okay, and in CUDA program we are having one debugging um, uh, code is available, that is called CUDA-GDB. Okay, so this debugging programs on real hardware, in real GPU programming, if you have used CUDA GDB, so it will do some debugging for that. And here also you can use breakpoint, single step, read write memory contents. All these things we can do there in CUDA-GDB. Okay. Already we have executed this particular program. If possible, I could take column 3. So this is a program. So already we have seen this having some error. So it is not executed. Okay. Yeah, here x is assigned to 0, x is assigned to some null value. Okay, so we have executed it. It is not returning any output. Okay. See here, the same thing. So it won't print anything. Here the printf statement is not given. Anyhow, we don't get any result. If you have given the printf statements, it won't print anything. Okay. And after that, we have defined something like CUDA error. Okay, this also we have done. See here, get CUDA get lost error. Okay, so it is printing some error equal to 700, illegal memory access, all those things. Already we have executed. Okay, some other errors uh, statements available in CUDA are CUDA success equal to 0 means no error. Okay, so after calling that means after launching the kernel, so you can check whether CUDA success is equal to 0 or 1. Okay, if it is 0 means there is no error in that particular program. Okay, whether it is a memory referencing, so or something else, there is no error. Okay, that means your CUDA success variable will be giving the value as 0. So there is called another one is called CUDA error missing configuration. So if it is 1, it means missing configuration error. Okay, so if there is any configuration error, that will be given. CUDA error memory allocation. So if it is 2, that means memory allocation error. CUDA error initialization error, that means initialization error. Okay, launch failure. Okay, if the kernel launch is failure, you will get the 4. And CUDA error prior launch failure. Okay, so there is launch timeout. Okay, so if you are launching some function to the GPU, but you didn't get to get any result from the GPU, that is launch timeout error. CUDA error launch out of resources. Okay, there is no resources means it will also give the error with the help of, you can get the error with the help of CUDA error launch out of resources. CUDA error invalid device function. Okay, and your device is invalid. That time you can catch that particular error using this. CUDA error invalid configuration. So the for invalid configuration you can use CUDA error invalid device function, device. So all those things are available. Okay. So next is how we can see the debugging function using CUDA. Okay. So you can generate debug information for using um, this statement, this using file.gu. So you can run it with CUDA-gdb. Okay, so what you have to do is you have to first execute the program, you generate the object code. Okay, so after that you call the CUDA-gdb. After that you write the output file name. Okay, so then you will get all those things. So we'll see one by one. Already I have executed. Wait 1 minute. So this is a hello world program. Sorry, it won't execute. Just a minute. Okay, it is in GPU only, no problem. Okay. So then after that I'm executing that. Okay, it is printing the hello world. How many times? 32 times. Okay. So already we have seen NV profiler. Okay. So what you have to do is here you have to generate the debug information. Okay, that is generated. Okay, so here our output file name is given as hello. So CUDA GDB, CUDA hyphen GDB hello. Okay, so it's created the debugger. Debugger is running now. So our CUDA version is 11.8. Okay, so who is having the copyright CUDA GDB version? It is a free software foundation. Okay, so what about the license of that? There is no warranty. So all the information relevant to that is there. So after that, you can give some comments. Okay, if you click on here, CUDA GDB, you can be able to give some comments. What comment first you have to give is, shall I give the run? Okay, so while giving run, what happens? It is executed. Okay, that already we have given the object file name here. Okay, so if you have given a run, what happens? Just a minute. It is executed, and so what thread is used, everything is correct. So there is only one process. So we are having only one kernel. Okay, so exited normally. That is shown here. Okay, so if you are more a number of threads, what the CUDA GDB will do is it works with the focus of current thread only. Okay, if you want to execute this particular program, it will give some other results. It will show you. It will take some error program. Oh. So now I am using here in this particular notebook, so that I have terminated there. What we have to do is, but we have to generate this one. See, then code. Output file name is x. Sorry. Try to execute this one. See here. Okay, starting program, error disabling address space randomization, operation not permitted, thread debugging using lib thread. Okay, so what happens in that particular error? That will be shown. Thread 1x received signal CUDA exception quoting wraps illegal address. Okay, so it will try to do many things, but it is not executing because our program is having some error. Okay, here we are using integer, here we are using characters. Okay, there are different errors are there. So that will be shown here. The help of that. Okay, info CUDA kernels. Info CUDA kernels. Info CUDA kernels. So there is only one the kernel is there. So even this is a error program. Okay, anyhow it is having one kernel program. Okay, so that is shown here. Okay. So I'll execute all those things for correct programs. Not to change it. Okay, CPU will go here. So this is a program for adding two numbers or two vectors. This executed. Sorry, it is written. And after that, what we can do is we can compile and execute. What happened? I don't see you. No problem. So we are getting the result. Next. We do the profiling later. Generating. Sorry, this add. Then we have to start the debugger. Okay, debugger is started. Then again I am giving the run. See, programming is executed. Starting the program. Disabling address space randomization. That is there is a warning. It's not a problem. And there is one thread is used, LWP thread for child process. And again another one thread. So result is 8. Okay, so all the threads have been exited. And so on the process, we are having only one kernel. Okay, that is exited. See that statement for CUDA kernels. There is no CUDA kernels. We are having CUDA kernel no. Info threads. Everything is exited. That's the reason, no? Yes. Okay, all the threads have been exited. It's not in running stage. That way it is showing that what I am trying to do is not free. So without exiting this one, that won't execute. So you can give all the commands there in that particular program. So you will get the results accordingly. So what block is executing? CUDA block 1 thread 0, what is it? So and CUDA kernel block thread, what is it? Which one is which block, which thread? That will be shown. So try it for some other program. There is another one program is there. Let us see for it. We have to change the file name. First we'll do this. File name is ex. Compile and execute the X. Debugger started. Then we'll try some of the commands. Info CUDA kernels. Phoenix saying there is no debugging symbols found in EX. Why? Sorry. What you have to do is first we have to run. Then only it will get something. Okay. So after that, you give. Okay, first you have to run. I forgot to run. I don't know whether it is given. It's not CUDA kernels. Info threads. No threads. Because all the threads have been exited. Okay. So also, I'll check it out and I'll tell what is the problem behind this particular problem. Okay. So next we can give the breakpoints. Okay. So if you give some breakpoints in between them, and you can check whether how the code is executed, whether the code is executed correctly or not. Okay. And so here, instead of giving main, so you can give the break main. Okay. And set CUDA break on launch application and break file.cu. Then you can if you can give that like that. Your thread ID is equal to 1 and I is less than 5. You can give the some breakpoints. Okay. So you can give the breakpoints in different steps too. Okay, not in a single step. So like our C program, so you can check breakpoint, no? Likewise, here also you can give info CUDA SMS. I'll try this, but I didn't know whether it CUDA SMS. Set on any active CUDA kernel. So the other commands are not executing. So I think so it may executed in actual machine. I think so. Info CUDA parts WARPS. I think that is the problem. Here everything is exited. Once it is completed, so all the thread has been exited. Okay. So while executing in other machine, what happens is the process is there. Okay. So we have to exit from there. Okay, so we'll see later. Okay, these comments are not working properly here. So already we have seen in the last class we have executed and NB Okay, so to check the performance of your program, we can use the profiling and okay. So here you can get the performance of your program. Okay, so there are some measuring indicators are available. So that is the time taken by various kernel used in that particular program, memory utilization, number of cache misses, intrusive or non-intrusive. All those things we can get it from the profiling. Okay, so to know the performance of your CUDA program, you can go with profiling, and you can have command line profilers and visual profilers. So NVProf is a command line profiler, and NVVP and NSIDE, these are visual profilers. Okay, so while executing code on the actual machine, you can get the visualization of all the performance of all the threads and all the process, everything we can see. Okay, and so here there is nothing need to be changed in the binary code. Okay, so what is the binary code? Even you can simply use that. And so already we have executed that there in NVPro. There is one program. Okay, so preparing process 1134 and our file name, that is actually the object code name. So that's the output of this particular program. Okay, so what is the GPU activities? How many API calls? So all those things we can see. Okay, so already yesterday itself I explained. So I'm going to stop this. Okay, so what happened to this? I'll check it out and I'll tell. Restart the runtime. I'll write the code once again and execute this. After that, we'll see what happens while doing NVProf. See. So in the previous one, what happens is, what is it? It is here. Okay. Here in this program, the GPA activities is very high. So 100% GPA activity for 19 milliseconds. Okay, there is one call for adding the vectors, and all the remaining are API calls. Here in this particular program, see here, the GPU activity is splitted. Okay, so because we are having three kernels here, see here, in that program we are having only one kernel, kernel K1, K3, and K2 is also there, K2, K1, K2, K3. So three kernels are there. So here the, see here, the GPU activity is split into three kernels. Okay, so the 100% is splitted. Okay, to three kernels. So the first kernel it is 383 microseconds, and second 381, and third one the 341 microseconds. Okay, there are 100 calls are there in K3. Why it is 100 call? See here, there are 100 numbers are there. Okay. Okay, so and in here also 100. The value that assigned is up to 100. So 100 times it is called. Here also. Okay. After that, you're having the API calls 100, 300. That for CUDA launch kernel. CUDA launch kernel happens 100 because uh, atomic add in domain. See here, there is one for loop. Okay. Under the for loop, the kernel is launched. Okay, that's why it happens. Okay, and K2 is also called launched 100 times, and K3. Okay, that's the reason CUDA launch kernel. Okay, the call is also 100 because of that only. Okay, and CUDA device synchronize also 300 times. CUDA device get attribute 101 times. CUDA device get name one times. All the remaining things are one. Device get two times. Okay. So this one this is a in this way we can get the performance of all the processes and all the kernels, all the API calls available or needed for that particular program you have written. Okay. Okay, you can also write CUDA profiler as a part of the program. Okay, for that, what you have to do is you have to write use the CUDA profiler start and stop functions. Okay, so you have to include CUDA profiler underscore API.h, and it has to be started in this way. So I didn't check it out. Okay, so if you want, you try that one. So this program, so here in this example, okay, the process number is given and application 39.6. Okay, so this I have taken it from somewhere. So based on the GPU available, it will be you will be getting different execution times. Okay, and API calls too. So here NVProf, it supports device specific profile. Okay, so it will provide what type of GPU device you are using in your particular machine. Based on that, it will provide the performance. Okay, so it also supports remote profiling. That means if you are executing some programs remotely, that time that GPU for that GPU also you can get the performance. Okay, and so what are the things you get it from this particular profile? You can save it as a CSV file too for future reference for our otherwise your performance comparisons or uh, how we can achieve the better performance using some other or some other way of programming. Okay, so if you have used some two or three kernels, that time your execution time is increased, or you need some other kernel needs executor faster. That time, based on your performance of NVProf contents, you can change the code accordingly. So the NVProf details are available with this particular line. It is available in NVIDIA website. Okay, all the things are available there. So there are some two visual profilers are available, NVVP and Insight. Okay, so visually it shows some graph and all for how long it takes execute in on particular GPU and what is the execution time. Okay, all those things it will be executed. So anyone want to try this program? Please try. So I will paste any pro. Okay, you kindly check the CUDA version available in your machine. So you can easily check the CUDA version. I'll show the command. Just a minute. Device with compute capability 8.0. So, what is the device available in your machine? That is GPU. What type of GPU? NVIDIA, some other Tesla or GTX. Oh, so you check that. Uh, so, is it a laptop or a computer, PC, or workstation? Oh. So, you give the command NVIDIA hyphen SMA. You can easily get this command NVIDIA hyphen SMA. Runtime is CPU. That's why it's command not found. Give the command in command prompt. You give NVIDIA hyphen SMA. So what takes say 500? Okay. I think it will support. What takes a 5000.
Hello, ma'am.
Yes, yes.
Yeah, so the system, the program which I'm actually trying to solve is a like a combination of files. So it's a CUDA plus C. So
Yeah.
what I will do, I will actually use a command like make clean to ands and clean. So after that, it will compile. Then after there will be a dot slash main command.
Okay.
So for that, what I'm trying to do is uh, like for that I'm trying this command nvprof, I mean nvprof space dot slash main. So when I'm doing that, it's showing this error.
So before that, have you executed the any program?
Yeah. I mean, so this is to show the whatever it is happening in the background, right? Like for example, the profile visualization in NVVP.
Mm.
Yeah, so I tried NVVP also. NVVP space dot slash main. So
Mm.
it is like some pop-up is came, but in that it is written that this profile viewer is not supported for this 8.0 and higher
So
profile.
uh, uh, so this visual profilers,
Yeah.
we have to install something.
Oh, okay,
Yeah, NVVP. So
okay,
NVProf, it is already available.
okay.
Okay, so if you have given NVProf, it is there in that all the systems. So if you can give in command line, automatically it will tell what is happening there in that particular object file and
Okay.
executing the object file.
So,
So
so
for NVVP and Insight, you have to execute something.
so we have to execute something and then that.
Yeah, we have to install something.
Okay.
Okay, in some machines it may have, and most of the time, I don't remember the file name. So we have to do something. Then only
Okay.
we can able to visualize all the things.
Okay.
So already we have done something, but I don't remember now. I
Okay.
didn't try now the Insight and NVVP.
Yeah. Okay.
So
Okay.
and NV Prof is a easier one.
Yeah. Yeah. Okay.
And so if your machine is having above CUDA 8, you can easily do this.
Okay. Okay.
Okay.
Yeah. Okay. Thank you.
Mm, okay. So I'll try this these two things and I'll tell. So what are the things you have needed? Okay, I have concentrated only on MD Prof. Okay, so in today's class, we have seen something about how to obtain the, how to know the performance of CUDA program and how to debug program. Okay, so what are the commands are available? Okay, how to make a CUDA file. So if you are doing or if you are developing some larger projects, that time how we can combine all those files and make the program to run using a single make file. So all those things we have seen, but the debugger didn't work out for some of the commands. I will try one more time and I will tell what you can do with that while executing in Colab. Okay, so if you are executing that command using some command prompt in the machine, so which is having the GPU, that is something different. You won't get the same feel while writing programs on Colab. Okay, so I have tried up to that. Okay, so that's all about today. So we'll see tomorrow uh, from a different topic. Okay, thank you. Thank you all.